then FIRST stands for Inspiration and Recognition of Scientific Technology. And then there's a bunch of other programs under the FIRST umbrella, like FTC, First Tech Competition, and FLL, First Lego League. Yeah, but FIRST is the best. FRC is the best. Okay, what's the point of FRC? You know, like, what's the point of robotics? So, the FRC's whole thing is there's a new game released in January, and we have a huge watch party, and so, like, we didn't have it during COVID because obviously we were all separated and everything, but just like last year, after COVID eased up, we were able to watch the kickoff at another high school, and you all kind of celebrate with other high schoolers. Maybe you attend like a workshop or something. It's really cool. Oh my god, last year's game was not Rapid React. It was Charged Up. Sorry.
Rapid React was better though.
Rapid React was better.
Yeah, Rapid React was better. Anyways, we'll tell you all about them.
Don't you guys like basketball?
Alright, so
What? No,
I
you
still
want
have
more.
more to say.
Oh, you want more to say? Okay,
No,
Matt,
no,
you
it's
say
fine.
something. No, how?
It's fine.
Okay, fine.
Yeah. There's
So,
like games like
how do we-
basketball. Pretty fun.
Okay. How do we split our time? So, since you just heard like the game is released in January, so like what are we doing right now? Right now is the off season, and so before the game is released, we spend time honing our skills and training new recruitments like you guys, so that you guys actually know how to build a robot, because that's like a pretty big task, right? And we also participate in off-season events. Like last year, we participated in an off-season event at Billerica, and that was pretty fun because you get to see other teams too. And then once the game is released, we immediately start brainstorming. I think last year we did the day after. We brainstormed for a good 3 to 5 hours. It was amazing. And then we read the game manual. Okay, put that in your head right now. You have to read the game manual. It's like 70 pages long. Basically, all of it is important. Okay, you don't have to memorize it.
There's about 10 pages that are important.
No.
She's lying.
All important, okay? And then during the competition season, we also have more meetings, so we do expect a little bit more of a time commitment, unlike what we have right now.
So about the current schedule and time.
What about it?
What about it? We meet on Mondays and Wednesdays
Like
from
today.
7 to 9.
Today's
Today is neither a
Today's
Monday or a Wednesday.
Sorry.
Today's
But yeah, we will meet every Monday and every Wednesday from 7 to 9 up until January 6th, which is the
Kickoff.
kickoff. And then
Woo!
after January 6th, we basically go into crunch time. Yeah.
So there's a meeting tomorrow?
Yeah, there's a meeting tomorrow.
No, I already checked.
Hello, welcome in. Okay, next slide.
Excellent.
Thank you. I changed this. Sorry. What was Charged Up? Please ignore this. We're gonna play Charged Up because Charged Up was really cool.
Rapid React was better.
Okay, do full screen. Full screen.
Yeah, Rapid React is actually better. Charged Up is overrated.
It's basically like renewable energy and stuff.
Renewable.
Oh,
No.
Can you hear this?
Yeah.
A man has fallen into the river at like
Charge up their community. The alliances earn additional points if their robots are docked to or engaged with their charge station. Robots start each match in their community and may be preloaded with either 1 cube or 1 chroma. Each alliance may choose where to stage 4 additional game pieces. During the first 15 seconds of the match, robots are autonomous. Without guidance from their drivers, robots score preloaded game pieces, collect and score additional game pieces, and are docked to or engaged with their charge station. Charge station points earned during auto count towards a potential activation bonus. The grid has nodes specific to cones and cubes, and some where either a cone or cube can be scored. During the remaining 2 minutes and 15 seconds, drivers control their robots. Robots continue to collect cubes and cones from human players at their substations to deliver power to the grids in their community. Each community contains 3 grids. The center grid is the cooperative race to their charge stations. Alliances earn points for each robot docked to or engaged with the charge station. Earning enough charge station points earns the alliance the activation bonus. The alliance that earns the most points wins the match.
Alright, so alright, basically this is just an example of the game that was played last year. The whole basically point of this is we basically train up from now, as I said earlier, until January 6th is going to be basically nothing but making you guys be able to, I guess, compete, or I guess participate, like, trying to figure out the best way to phrase this.
To compete.
Yeah.
To build the robot.
We have from January 6th to whenever we
March, something, mid-March.
mid-March. We basically have that amount of time to build a whole robot from scratch. The weight limit for the robots is about 125 pounds, and we kind of want to be near that. So that's basically what this is. We won't know what what the challenge for this year is until January 6th, but that's basically the whole thing.
Oh, who did the thing?
Okay, cool.
Okay, here's our original robot design, which it looks nothing like right now because actually we just took it apart this weekend. So part of it is on the ground right now.
Yeah, if any of you guys would actually, all of you probably saw Set Club Fair. Yes?
Yeah.
Awesome. Yeah.
This was our original design with pneumatics, which was amazing. It was lovely.
Love
We
pneumatics. Love pneumatics. They're the best.
And then some other robot designs are
More?
like an Everybot, which is a basic robot that can achieve the minimum to like score some points in the game and play in the game. It's for teams that like maybe kind of struggle with their ideas or don't have enough resources. And so this is usually costs around $1,000 build, so like not bad. And it's built as a side project by Robonauts. This was last year's. So there's an arm and intake and stuff, and it's pretty cool. Bare minimum. And then some other robot designs. Is like FSC-95. They're pretty cool. And that's their design. So it's like an arm that shoots like up and stuff. And then Osram. And there's a cube in their intake, and then the intake basically shoots the cube out onto the stairs that you saw. And then I think there's one more. Yeah. Oh, well, yeah, here's our robot. It looks nothing like that right now, but yeah. Anyways, yay! Thanks for coming.
No, wait.
Alright.
Alright, so I don't have my slides with me, but that's fine. Well, I do. They're right here.
Okay, sure, let's swap so that I can do.
Alright, cool. So, main, like, sorry, give me a second. The actual, like, process for how we get all this stuff done is, there's two, I guess, main groups and we're gonna split into those groups sometime during training. We're gonna do a little bit of basic training, and then we're gonna split into mechanical and software. So, kind of, as we're going about this, think about whether you want to, which kind of direction you want to lean in, right? For mechanical, it's mostly going to be all of the physical elements of the robot. Stuff like a lot of the metal, right? Cutting the metal, CADing, basically the whole thing. CAD is very important for mechanical and just the robot.
Do you guys know what CAD stands for?
Anyone, please, Mr.
What does it stand for?
Computer assisted design.
Woo, that's right. Computer design. We use I forgot the name of the program. Yes, Onshape. We do use Onshape. And there will be a kind of length. It's not super lengthy. It's fairly lengthy. Training on just how to use CAD, because that is very integral to the robot existing. Another big part of mechanical is prototyping, because if you don't prototype, right, it's probably not going to work in practice. That's something that we've kind of learned time and time again. The more you prototype, the better the outcome will be, right? And then building the actual thing. Software, do you want to talk about what software does?
Sure.
Are you gonna stand up?
I could
Please
stand
come
up.
and frame.
I'm not standing away from my chair, Tyler will steal it. So, we have there's a few important parts of software. First you have to have a robot to work on. Then you get to writing some code. You have to do this pretty quickly. It's important to be fast with writing code. You do it in Java if anyone cares. You probably testing. You run it on a robot, and then sort of falling into testing, we do this thing called PID tuning. Does anyone here know what control theory is?
You'll
Okay.
learn.
You'll learn.
What is it, Justin? Justin, please explain. Please.
It's when you have your motors and you basically need to tune them so that they're good with each other, basically, and they're not unaligned.
That's a part of it.
A part of it. Yeah.
Anyways, basically, control theory is basically how to get your motors to do what you want them to do, and how you basically find the most efficient ways to get them to run at the speeds you want. It's a little bit complicated. If you do software, you can learn.
All right, and then the next big thing about how the team functions is subteams, which is basically when we're actually building a robot and we're starting off, there's a lot of different components that go into the robot, whether that be the drivetrain, which is basically just how the robot moves, whether there's an arm on board, there's usually an intake of some kind, which is just how you intake objects, all that stuff. This is an example of an intake. This is the intake that we had last year. It will just inhale cones and cubes. It does that. It's pretty cool. It eats it. It just spins and then it eats it. That's an intake. All of these pieces have to come together, and that's why CAD is really important, because if you don't CAD the whole robot, you'll end up with a little less space than you intended, or just basically a lot of bad stuff happens when you don't CAD accurately.
Hard to put together.
Exactly. Because when each sub teams basically, sorry, I'm trying to put my thoughts together. Sub teams each kind of work on a piece of the robot, and each of those pieces have to have mechanical components that go into it, and also software components for the code. I actually don't. How does?
What?
Do you want to explain that?
What am I explaining?
I don't know what
You
I'm
have to
saying.
code the individual.
You do have to-
for the
You have
each
to,
individual
You
system.
have to, write the code so you can basically control the robot. If you don't know, basically have a bunch of Xbox controllers that we just use to drive our robot. Coding, basically you find the best way to put that together, control the robot.
Yep.
Just make it efficient for the driver, make it really easy to ignore, basically.
Yeah.
So, all that stuff.
That's that. Next. Is it next slide? It is next slide. This is important dates. You should probably know these. These is the stuff that we already went over. This is just we meet Mondays, Wednesdays. Jinglan, you said something about attendance requirements at one point, I think?
Yes, this year we're trying to be once a week. We have, we meet twice a week, and we understand some people may not be able to make to every time. So like any sports team, so we kind of consider our team as a sport team almost, because it's all kind of compete with during the winter game. It's winter time is when we actually compete. So for any sport team, there's attendance requirements. So we're piloting to say once a week. We think that's pretty reasonable, but do talk to us if there's anything that you have any thoughts about that. Anyway.
Also, donut sale fundraiser.
Y'all should
That's
come
coming up. If you want to show up and help us sell donuts, that would be cool. That is October 14th. And then kickoff is January 6th. That's another really important date, because that's when competition, I guess, not competition itself, but actually working on the real robot that we're going to use for the year starts. I think that's everything. Is that? Yeah, why do robotics? Why should you be here? These are my main three. This is why I personally enjoy robotics. The thing with engineering is it's a very important thing. It's probably the reason why a lot of you are here, is because you're at least somewhat interested in engineering, if I had to guess.
I'll just ask really quick though, is anyone here interested in the business side of robotics? If so, we need to get you in touch with our business person.
Yes,
Help a lot.
talk to me if you're interested in the business part of it. We have marketing, we have social media, we have fundraising, grants writing, writing stuff. So anything, we can find a role for you, whatever you want to do. Photos, if you are interested to do photography, videos.
But yeah, engineering is obviously a big part because you have to make the whole robot, and that's like basically the full engineering process right there. Community, the FRC community as a whole is really great. It's extremely chill. During the actual competition, basically, okay, this is gonna take a little bit of explaining, but last year during competition, we needed to take our robot apart and then fix some stuff on it because we basically cut off the entire top of the robot just so that it could move faster and play a little bit better at defense and score on bottom easier because that's what our teammates wanted. But we kind of were lacking stabilization, if I remember correctly, and we needed just a beam, just an aluminum beam. So we asked around, and within like a minute or two, one of the teams was just able to offer us just an aluminum beam, and we were like, I think actively competing with them, but it's just the community at FRC is really nice, and if something breaks in your robot, you can probably ask around and somebody will be willing to help you out with that. And experience, this is like kind of a really unique experience at FRC. Like just the FRC program as a whole, the robotics team, a lot of the stuff that you're gonna be doing here isn't stuff that you would really be able to do in a classroom. And it's stuff that I value, and I feel like a lot of other people value here. It's a grand old time. That's why I think you should do robotics. And that's like the end of my slideshow. All right, any